Okay, so we're going to continue the elimination with the originally titled Elimination Lesson Part 2. So I think we're on example 3, if I recall correctly. So example 3 is going to be 5x plus 2y equals 18, and 3x plus 2y equals 10. Now if I try to add these up, there's going to be a problem. The problem with adding it up is 5 plus 3 is 8, 2 plus 2 is 4, and nothing's been eliminated. There's no, right? Nothing's gone. So that's not going to work. So we need to do something different here, slightly different. So what I'm going to do in this case is I'm going to take equation 1. I'm going to multiply equation 1 by 1 multiplied by, how did I phrase it before? Yeah, multiply by, because they're almost the same. Notice the 2's are the 2. So all we have to do is we have to make one of them negative. So I'm going to multiply the first equation just by 1, and I'm going to multiply the second equation by negative 1. And I could have done it the other way, but I didn't. So what happens? We multiply first equation by 1, and nothing special happens at all. We get 5x plus 2y equals 18. We multiplied the second one by negative 1. So what happens now is 3 times negative 1 is negative 3. 2 times negative 1 is negative 2. And 10 times negative 1 is negative 10. And now we can add these guys up. And if we add them up, we're going to get 5 plus negative 3 is 2x. 2 plus negative 2 is explosive nothingness. And 18 plus negative 10 is 8. And so now it worked. We were able to eliminate one of the variables. I keep on eliminating x. I think in the next example I'm going to eliminate, I keep on eliminating y. In the next example I'm going to eliminate x. So what we have is we have 2x equals 8, x equals 4, and then the usual sub x equals 4 into equation 1. So we get 5x plus 2y equals 18. 5 times 4 plus 2y equals 18. 20 plus 2y is 18. 2y is 18 minus 20. 2y is negative 2. Y is negative 1. So therefore, solution to linear system is x equals 4, y equals minus 1, or I could have written it as 4 and negative 1. That's that. I'm going to show another way of doing it. So same example. So example 3 yet again. So example 3 was 5x plus 2y equals 18 and 3x plus 2y equals 10. And what I could have done, instead of multiplying this by negative, so what I did in the previous one is I multiplied it by negative 1 to get it to, I multiplied this equation by negative 1 so that we could get the opposite signs and add them. What you could do instead, if the signs are the same, is you could subtract it. All right, so you could subtract instead of add. And either way, you're hoping to eliminate something. So we get 5 minus 3 is 2. 2 minus, then it would be 2 minus 2 is nothing. And 18 minus 10 is 8. And then we have 2x equals 8. And we're right back to where we were before. I don't really care which way you do it, but you've got to be consistent. So I would say pick one and then only do it that way, because if you start doing it both ways, you're going to mix yourself up a bit. Much like I just mixed myself up there a bit with my wording. Okay, last example. We have example 4. Minus 3x plus 2y equals 19. 5x plus 7y equals 20. Oh, I forgot something very important, actually. So I said I was going to come back to it. But how did I know to multiply by 2 and to multiply by 3? So one thing you could do, like technically what you're supposed to do is you're supposed to say what is the least common multiple of 2 and 3. So what do 2 and 3 both go into nicely? And the answer is 6. They both go into 6. However, it's always going to work out that you could always multiply by the coefficient of the other equation. So this equation had this equation we multiply by the number in front of the y. So we multiplied it by 2. And then for this equation we multiply it by 3, which is the number in front of the y in the other equation. And it's always going to give you not necessarily the least common multiple, but a common multiple, and that is all you need. So over here, let's say I wanted to make the x's the same. So what I could do is I could do equation 1 multiply by, so I'm going to multiply this one by 5, and I'm going to multiply this one by 3. And then that would give us, so minus 3 times 5 is minus 15x plus 10y equals 95. We multiplied it by 5. And then we're going to multiply this one by 3. So we're going to get 15x plus 21y equals 60. And now the numbers in front of x are, it's the same number, but one's negative and one's positive, which means we are ready to add them up. Negative 15 plus 15 is eliminated. 10 plus 21 is 31y. This is going to be 155. So we get 31y equals 155. Divide both sides by 31. And y equals 5. Notice we solve for y here and not x. And so when we have to be careful on the next step that we actually sub it in correctly. So we're going to get, so we're going to sub y equals 5 into, I'm going to put into the second equation this time. For no special reason. Well, the reason is that that negative creeps me out a little. I don't want to put it into an equation that has a negative. This one has only positive numbers, so it looks prettier. So 5x plus 7y equals 20. So it's going to be 5x plus 7 times, right, 7 to 5 equals 20. 5x plus 35 equals 20. 5x is 20 minus 35. 5x is minus 15. Divide both by 5. And we get x equals negative 3. And then we can finish it off, of course. Therefore, solution to linear system is, I don't remember the fancy way we would write it. So we could write it as x equals negative 3, y equals 5, or we could write, since it's x and y, we could write it as a point. The solution would be that. I'm going to show you another way of doing the exact same one. So it's going to be example 4 yet again. So example 4 yet again was minus 3x plus 2y equals 19. 5x plus 7y equals 20. And let's say, so before I decided I want to make the x's the same, so what I could do here is I can make the y's the same. So if I want to make the y's the same, That's equation 1, that's equation 2. If I want to make the y's the same, I'm going to multiply equation 1 by, so here I look at, if I want to make the y's the same, I multiply by the coefficient of y in the other one, or the number in front of the y in the other one. So I'm going to multiply by 7, and I'll multiply equation 2 by the number in front of the other one. Multiply by 2. So, negative 3 times 7 is negative 21x. 2 times 7 is 14y. 19 times 7 is, reach for the calculator, 133 apparently. Then if we multiply by 2, we're going to get 10x plus 14y equals 40. Now maybe I probably should have multiplied by negative 2 if I want to add it, but since they're the same sign, I'm going to actually subtract it. So I'm actually going to subtract here. Again, if you were going to do it by the adding technique, I would have multiplied by negative 2 at that step. Minus 21 minus 10. We have to be careful. That's why subtraction is harder. It's minus 21. It's the top minus the bottom, which is minus 31. 14 minus 14 is... And then 133 minus 40 is 93. So minus 31x equals 93, divided both sides by minus 31. And we get x equals minus 3. And then we sub x equals minus 3 into, again, I'm going to do it into equation 2 because, so 5x plus 7y equals 20. 5 times negative 3 plus 7y equals 20. Minus 15 plus 7y equals 20. The minus 15 goes to this side, becomes positive. So 7y equals 20 plus 15. 7y equals 35. And then y equals 5. And then we have the same answer as before. Okay. And that's that. If you have any questions, you can post them in response to this video. If not, I'll be posting a worksheet either today or shortly. But what I want you to do for now is, so let's have our examples. Let's see if I can grab them. And of course they're gone. No, I can see them. So it's going to be 3x plus 2y equals 17. 7x minus 2y equals 33. That's the first one. 4x plus 3y equals 34. 5x minus 2y equals 31. 5x plus 2y equals 18. 3x plus 2y equals 10. And minus 3x plus 2y equals 19. 5x plus 7y equals 20. So I want you guys to try those 4 examples. Do it by yourself until you could do it without referring to your notes or to the video. Good luck.